Today I'm gonna talk about the derivative of composite function chain rule. I'm gonna focus on the general power rule and product rule. Now let's take a look at the following formulas. The first formula is about product rule. The derivative of fx times gx equals the derivative of fx times gx plus fx times the derivative of gx. The second one is the general power rule. The derivative of fx to the power n equals n times fx to the power n minus 1 times the derivative of fx. The third one is standard power rule. And here we have a very special case. The derivative of x equals 1. And the fourth one is the derivative of a constant equals 0. And the last formula is about the constant multiple rule. So we can pull the constant out of derivative. Okay, now let's take a look at the first example. For the first example, if we apply the product rule, we need to identify what is fx and what is gx. Here it's very clearly the fx is x squared plus 1 cube. Okay, that is fx. And what is gx? Gx is x squared plus 2 to the power 8. So that is gx. Now we can follow the product rule. We have the derivative of fx. So we have x squared plus 1 cube prime times the gx, that is x squared plus 2 to the power 6 plus the fx. Fx is x squared plus 1 cube times the derivative of gx, x squared plus 2 to the power 6 prime. Okay, and now let's focus on the derivatives. X squared plus 1 cube and x squared plus 2 to the power 6. And it's very clearly we can apply the general power rule. For the general power rule, we need to find what is fx. For this guy, we can tell fx is x squared plus 1. Right? And the n is 3. And for this derivative, we have fx equals x squared plus 2. And we have the n equals 6. Okay, now let's follow the general power rule. So we have n times x squared plus 1. Fx is x squared plus 1 to the power n minus 1, that is 3 minus 1, times the derivative of fx. So that will be x squared plus 1 prime. And copy this term, we have x squared plus 2 to the power 6. Similarly, for this derivative, so we copy x squared plus 1 cube and times n is 6. And fx is x squared plus 2 to the power n minus 1 times the derivative of fx. Again, let's take a look at these two derivatives. Okay, here's x squared plus 1, here's x squared plus 2. Okay, it's very clearly for the first derivative is the derivative of the sum of the two functions. Okay, so that means we can do the derivative for each function. Similarly, here is the derivative of the sum of two functions, and we can do the derivative for each function. So let's simplify. Then 3 times x squared plus 1 cube, and for the first derivative we do the derivative for each function. Okay, and a copy x squared plus 2 to the power 6 plus x squared plus 1 cube 6 x squared plus 2 to the power 5. And again, here we're gonna do the derivative for each function. Okay, now let's check the derivative. Here x squared, derivative of x squared, we can apply the standard power rule. Okay, so here we can write the x squared as 2x to the power 2 minus 1. Okay, and for the derivative of 1, we can apply the constant rule. Okay, equals 0. Okay, and for this guy, again, we can apply this power rule. We have 2 times x to the power 2 minus 1, and the derivative of 2 gonna be 0. That is constant rule. Okay, now we can simplify all of them. 3x squared plus 1 squared, here is 2x times 2x times x squared plus 2 to the power 6 plus x squared plus 1 cube times 6 x squared plus 2 to the power 5, and here should be 2x. Okay, now we can simplify it. 3 times 2x gonna be 6x. Okay, 6x times x squared plus 1 squared, and here will be x squared plus 2 to the power 6. And here let's take a look. Here we have 2x, we have another constant 6. 6 times 2x gonna be 12x. So times x squared plus 1 to the power cube times x squared plus 2 to the power 5. Okay, now let's take a look at the second example. For the second example, we have two functions multiply together. So that means we can apply the product rule. Okay, for the product rule, we need to identify what is fx, what is gx. So fx is 2x plus 1 to the power 5. Okay, that is fx. And for the gx, that is x cubed minus x plus 1 to the power 4. Okay, now we're gonna apply the product rule. We have the derivative of fx, so we have 2x plus 1 to the power 5 prime times gx, that is x cubed minus x plus 1 to the power 4, and plus fx, that is 2x plus 1 to the power 5 times the derivative of gx. So x cubed minus x plus 1 to the power 4 prime. Okay, for these two derivatives, it's very clear that we can apply the general power rule. For general power rule, we need to identify what is fx. So here, for 2x plus 1 to the power 5, we have fx equals 2x plus 1, and the n is 5. And for the second derivative, the fx should be x cubed minus x plus 1, and the n is 4. Okay, now let's follow the general power rule. N 5 times 2x plus 1 to the power 5 minus 1 times the derivative of 2x plus 1 times the x cubed minus x plus 1 to the power 4 plus 2x plus 1 to the power 5. And again, here we're going to follow the general power rule, that is 4 times the derivative of times the fx to the power n minus 1. Okay, so x cubed minus x plus 1 to the power n minus 1 is 4 minus 1 times the derivative of fx. So we have x cubed minus x plus 1 prime. Okay, now let's focus on these two derivatives. One is the derivative of 2x plus 1, and another one is derivative of x cubed minus x plus 1. So for this derivative, that is the sum rule. The derivative of the sum of two functions, that means that we're going to do the derivative for each function. And for the second one should be very similar. The derivative of the sum and or difference of three functions, that means we're going to do the derivative for each function. Now let me write down the steps. 5 times 2x plus 1 to the power 4. And here we're going to write down as derivative of 2x plus the derivative of 1 times x cubed minus x plus 1 to the power 4 plus 2x plus 1 to the power 5 times 4 times x cubed minus x plus 1 to the power 3. And here we're going to apply the sum or difference rule. We have derivative of x cubed minus derivative of x plus the derivative of 1. Okay, now let's take a look at each term. Derivative of 2x, we can apply the constant multiple rule. We can write it as 2 times the derivative of x. Derivative of 1, we can apply the constant rule, that should be 0. And the derivative of x cubed, we can apply the power rule, that should be 3 times x to the power 3 minus 1. And the derivative of x, that is special case, that should be 1. And the last term is the derivative of 1, so we can apply the constant rule, that should be 0. Okay, now we can write down each term. 5 times 2x plus 1 to the power 4. And here we have 2 times the derivative of x, gonna be 1, right? 1. So that means 2 times 1 equals 2. Wait, 2. X cubed minus x plus 1 to the power 4 plus 2x plus 1 to the power 5 times 4 x cubed minus x plus 1 cubed, and this guy will be a 3x squared. Here should be a minus 1 plus 0. Okay, now we can simplify it. 5 times 2 equals 10 times 2x plus 1 to the power 4 times x cubed minus x plus 1 to the power 4 plus, here's 4, so we have 4 times 2x plus 1 to the power 5 times x cubed minus x plus 1 cubed times 3x squared minus 1. That's it.